same.
Yeah, and so thank you very much, Sören. And I hand over to you.
Yes. Oh, microphone.
Yes. So, where's the beer? Ah, here is it.
This is yours? Where's mine?
Nein.
Ah, doch?
Yeah, all right.
Need to find the mouse somewhere.
So, hello everybody. As you see on the slides, I'm talking today about beer and small things. And we are starting with a simple question. Who likes beer? Hey, very cool.
So then,
cheers. But I won't start like some other guys doing presentations in Munich and saying that Bavarian beer is not good. Wasn't the best idea of his life. I anonymized it for data protection reasons. It's fine, I hope so.
You can see the number anyway.
Which number? And the small things I'm talking about today is called IoT, the cool Internet of Things, and it's a very often heard buzzword today's. And as you see on the slide, there are some solutions on it. So pick one out and try with it. The idea of the presentation today is to show you how this IoT stuff could work in a simple scenario without buying big solutions like Azure IoT or SAP IoT or something like this. And just for the first introduction of myself, who am I? My name is Sören Schlegel. I am Bachelor of Science in Computer Science at the University of Applied Science. I'm doing ABAP development since 2011. I am mostly focused on as developer for SAP ERP, SAP SCM, and also SAP Solution Manager, and also in the area of SAP Solution Manager charm. I'm part-time working as a consultant, and I'm a trainer for certification since 2013, depending on the project situation, sometimes a little bit playing around in the classrooms. And I'm working for Concilio. It's a German company based in Aschheim, near Munich, who knows it, and also in Waldorf, Ratingen, and Sofia. And the company is mostly focused on the production processes, SCM and ERP, and does also a lot of multiple S4HANA projects. And my role in the company is that I'm working as a managing consultant, and I'm also responsible for innovation topics and also HANA development. And according to innovation topics, I'm doing this presentation today. So, what can you do with IoT sensors? For example, how can you bring IoT and beer together? The both topics of today. One very important question is, for example, when is the right time to order your next beer? For example, in this scenario, we have an intelligent, how's it called?
Beer coaster.
What?
Coaster.
Beer coaster?
Coaster.
And it weighs it measures the weight of the beer, and if it's almost getting low, then okay, it's time to order a new one, or the service brings you directly to the next one. An alternative is displayed here by Donny Beagle. This is a Kanban principle. He orders 2 beers, starts drinking the first one, and when the first one is empty, then you can just order the next one, and in the meantime you have the other beer. And talking about beer, you have different types of beer. You have this one, the cool and fresh one, or this one, boiling hot. So what would you prefer? This one? Hands up? Hey! That's the right decision. In Germany we have a very famous saying, also kalt kannst du trinken. That's a lot of beer brands outside. Not that good, but if it's cold enough, you can also drink it. So, with this information that cold beer is a good one, and with our addiction to beer, we can start to make our beer intelligent. So, what are our building blocks on it? We need a sensor to measure the temperature of our beer, if it's still cold enough and good enough. Okay, there are also people outside who don't like cold beer. They drink beer at 20, 25 degrees. That's some kind of religious decision, but we accept, we are open for everyone. Our building blocks to our scenario we want to create is, we have a sensor, we have some kind of a data connection we need. We need a device to handle the data from our sensor. We need some kind of protocol for data exchange, and perhaps some middleware, and some visualization. With these ingredients, we can think about, okay, how can we build up our scenario? This guy had a presentation some months ago at I5Con and showed this slide where I blamed him as some type of copy and paste programmer. But to be honest, I have to say that for this presentation I did somehow the same. I looked for some stuff I want to do for my building blocks and how can I implement them. And then find the right solutions with the right typos, with the right search words on Google, and can start doing your job. So, what's our architecture? We have a temperature sensor. We have our, of course, we are SAP developers, we have our S/4HANA system on the other side. Then we need some intelligence, a microcontroller who picks up the data from the temperature sensor. And we need some kind of how to transport the data via Wi-Fi for sure. And we need a Wi-Fi router, or in my case, I have a laptop with a Wi-Fi hotspot. And this is our first network. And this network this does via VPN connection to the SAP system, just some architectural reasons I had to do. And as middleware, I use a Raspberry Pi to communicate with our microcontroller. And the protocol I used for it was MQTT. And this MQTT talks to NodeRED. Who knows RED? Well, who knows NodeRED? So less? Okay, we'll talk about later. And after having the data via NodeRED and master, we send the data via a REST API to our SAP system and visualize it in some way. So, what we have to do, collect data from sensor. That's the first task we have to make. Then we need some possibility to send data to the Raspberry Pi. As the next step, we need somehow to receive and handle the data on the system. Oh, good echoes. And then we need to perhaps do some logic on our middleware before we send the data back to the SAP, where we receive it and visualize it in some UI. So, what was the used hardware? I used ESP8266. This is this one in real life. You see it on the pictures. I think it's a little bit better to see because, yeah, it's a very cheap microcontroller. And I think everybody of you knows Arduino or Raspberry Pi, and this is the cheap variant for about €5. 2 to 5 euros, depending on where you buy them. And you see that's almost the same performance like an S/4HANA system. But I think it was almost the same computing power we needed to drive to fly to the moon several decades before. And we did a temperature sensor. This temperature sensor, this DS18B20, is typically this size, and compared to the 1 euro cent, the ESP is not very not large. What I used was this waterproof version of the sensor, just to have the possibility to measure temperature of the beer inside the bottle. So let's have a short look at it. So, here you see at first the data of the sensor, which are getting collected on this end. And if I put it just inside, I hope that it still is because it should be waterproof. Then we see our temperatures. The beer is hopefully cold, degreasing. If some of you decides to build up the same tutorial or the same scenario, I explain here every step you have to make, because you easily find your introduction, how to connect the microcontroller or the sensor to the microcontroller on this tutorial on the web. And if you think, oh, this microcontroller programming is very hard stuff, no, it isn't. So you find everything as templates on the internet where you can just copy it, adapt it, and reuse it. What you see here is about 30% of the complete code on the left side. On the right side, you see how such microcontroller programming typically works. You start with a setup method. That's when you plug in the power of the microcontroller. Then there are some jobs to do, like connect to the Wi-Fi and so on. And then you have a loop process where you say every 500 milliseconds, or in this case, about every 1000 milliseconds, I do send some data to, for example, microcontroller to a sensor to put some lights on or off, something like this. The protocol used for this scenario, for the connection between the Raspberry Pi and the microcontroller, is MQTT, the Message Queuing Telemetry Transport Protocol. Who knows this? Oh, not that much. It's somehow the industry standard protocol for such communication scenario. It's a very lightweight publish-subscribe protocol. Mostly text-based. You can also put JSON or something like this. And it has been developed since now almost 20 years. It started in 1999 as a private project. And the latest version of MQTT is 5.0 from beginning of this year. And the communication with MQTT to pick up the sensor data and send it by this protocol to our Raspberry Pi is that simple. We just have to connect to our broker in the middle of this. And then we have to read the temperatures of the sensor. The libraries are everywhere on the internet. And then just put the information via a publish to the final backend system. For those not knowing MQTT, you see on the other side, on the left side, how this normally works. We have a program, and this program normally first needs to connect to a broker. Broker, something like PI or everything else. And then we have different type of steps we are running through. The first event, when we successfully connect, is an unconnect event I can register on, and then we have the possibility to publish messages to this broker. Every message is connected to a topic, and if you are interested in the sensor data, then you need to know the topic on which the sensor data is publishing information. For example, in my case, I have defined, in this case, sensors P1 temp. And it's typically used that you build up some hierarchy for your measured data. Yes, if the publish is successful, the MQTT broker receives the message, then you get the unpublished event, it was successful or not successful, and then you have also the possibility to subscribe to other information, so to other topics. Because we have microcontroller A, and microcontroller A is also waiting for information of microcontroller B. To implement this, we need something from this company, the good old IBM, the International Business Machines, and the solutions that most people think of when they hear IBM, I think is this one. Everybody still know? Or the good old mainframes, and also the good old RPG programming. But IBM is also responsible for Eclipse, we all need for our ADT development, and for NodeRED. NodeRED is an open source tool based on Node.js, and it's some low-code engine for defining data flows. For example, you see a lot of tutorials on the internet. On the left-hand side, you have your Twitter account, Twitter input node, and do some transformation, save all your data in a MongoDB, and then publish it somewhere else. The broker, the MQTT broker I talked before, I choose is Mosca. Mosca is a plugin for NodeRED, just the simplest way. There are even a lot of others outside, like Mosquito, HiveMQ, and so on. And now we have some challenges to take. For example, okay, I have my MQTT data. These data are sent to NodeRED. They are worked around a little bit with. And then we need to send information back to the SAP system. How can this be done? Just do it very easily. Google on it, or Google for it, NodeRED OData. And one of the first responses you find is this blog post. And yeah, just use the information the community provides you to implement your solutions. But I had a problem with my flow that I have a problem on this part, so the demo is not that completed, but at least I tried. So just let's do a quick check. The viewer is still code, so we have some time. Now, when we send out the data via REST API from the NodeRED to the SAP, then we also have to think about how to receive the data in SAP. For this, you find another blog post under this URL, and SAP in these days always talks about OData. In some use cases, OData is, let's say, too complex. Instead of building a complete SEGW project and define my entities, define every method in this entity, I just simply want to put some data via a post statement into the SAP and use this to define this set beer input as SICF node and define a handler method for this, a handler class for this. So we have our NodeRED. On this sends the data to our SICF REST endpoint. In the REST endpoint, we implement first the first REST handler method, and you normally know that in URL you have some slash and paths in your URI. And here I just simply defined a handler method for the root / beer. This class is also not that big. I have two simple methods I implemented for the scenario. One is the get and one is the post, the typical HTTP operations. Who is not comfortable with this HTTP, get, post, put, something else, just a simple introduction. A user sees a website, he clicks on a button. With this click, he creates an HTTP get. This goes back to server. In this case, I have to use the Tomcat. This reads the request, what wants the user to see, prepares the website, and sends this back as response for a simple GET request. And then the user can enjoy it. In our case, we don't want to sit in front of the computer and press every time F5, F5, F5 to see our new sensor data. We want to be a little bit cooler, and for this we use so-called WebSockets. As I explained just now, we have the normal polling principle using HTTP, that I say get, I will get a new website, and then I say get again, I get a new data set. With WebSocket, it's a little bit other stuff. We open a WebSocket connection, and this WebSocket connection is normally not closes that fast. It's a long time open, and from the other side, from the server side, I can put some information on this WebSocket channel and deliver every time without user interaction on the other side information to the client. How to do this in SAP? Just use the great tool called Google, once again, and then you find a blog post of Gregor Wolf. I think everybody knows him. Who doesn't know Gregor Wolf? Oh, okay. In his blog, he just described how to build a simple UI5 application consuming the data. That was also my first idea to do so, but I had some problems with cloud connectors, and yeah, and I'm also not a UI5 developer. If you also want to understand the complete scenario and technical details, I attach also here some nice links. For example, these links he refers by himself in his blog. In his blog, he described, in his blog series, here is linked, describes how the communication via WebSockets and messaging channels and push channels and so on works. So normally we have a website, or some WebSocket client, we have to call it, and this WebSocket client talks to a session or program in some session, and these different programs talk again via so-called AMC. Yes, so what we have to do for it, we have to define another push channel. That's some new SICF node we create. And in this SICF node, we'll first call, we run through the onStart method. With the onStart, we connect our APC to some ABAP messaging channel. And that's all the code you need for this scenario. And then you have to define also your messaging channel and which methods and classes can communicate with this messaging channel. And if all this is done, Then, then you see something like this. This is a test application developed by SAP. It's a classical WebDim Pro. I think one of those of you still knows it. And normally the idea should be that you now see in this testing console every data I measure on the sensor. But I had some problems with NodeRED, so let's do a quick simulation. For this, I use just Postman, and with Postman, I can send data to every endpoint via post, via get methods, and something like this. And I already did some preparation. I defined my headers with my XCSRF token for application, and here is my body. And with the body data, for example, let's say we have 8.7 degrees. Click on send, and you see, oh, cool. We need to get a new one. So you first have to do a GET request, and this GET request with your application data delivers your XCSRF token, and this XCSRF token is needed for your further operations. And now we see that we have no error, and without refreshing the final page, I have the new data. And this, yeah, is the complete scenario. So, how is the complete communication to be implemented? We have our WebDim Pro test application. This test application calls our APC via the created sitHH node. With the first call, it runs through the onStart method, and this onStart method registers and combines our APC push channel with our message consumer and our messaging channel. And every REST call we do calls the input method for the set beer input, and stop copy paste, okay. And in the implementing class, we create a message producer and put some message on it, and afterwards, the messaging channel pushes information back to the registered APC. If you want to see the details, the graph looks like this. That's all the possibilities you have. You find this graph also in the connected, in the linked documentation. So our WebSocket client connects to our ICM node. On the onStart method, we register to the AMC. Messages can be sent to our AMC producer and then via sent back to our UI5 application. I also put some important transaction if you are working on it and trying to debug this whole APC and AMC scenario. It can also be used in a lot of different other scenarios. For example, you have some SAP UI5 application looking for your sales orders, and with some change on sales order, you can trigger a reload page via APC. Further ideas you can think about to implement in the future is, for example, like this shows some Alexa integration, some Office add-ins, for example, that I have a small window in my PowerPoint presentation showing the actual data. Or also very cool blog post is that NodeRED also offers some dashboards there's a blog post of, I need to look again for his name, who used NodeRED for monitoring SAP systems. For example, like how much dumps did you have and something like this. And you can also connect more sensors for some scenario or visualize your data via SAP Cloud Platform and UI5. So this was my general content. Just for a lot of people who are sitting here, I want to say some words that it's very cool if a lot of people participate in such formats like this here and also do some presentations, for example, also for DSAG. Just think about what idea you have, think about the building blocks you need, and search for some blog posts, some information, and develop your own scenarios, like a lot of presentators here today, and show this to the community so that everybody can participate from the knowledge and experience each of us makes. Just the last slide, I'm talking about community. There are some very famous persons outside, so very cool persons who will do a lot of work for community. For example, this one everybody knows. The inventor of ABAP, one of the most important projects in the SAP universe at the moment. Or some people like Gregor Wolf also organizing the sitHH and writing about 1.3 billion of blog posts. And also some other guys like Tobias, who also founded the SAP Stammtisch in Karlsruhe, Daniel Meyer, who's also at almost every format like this, who organizes his code retreats and teach a lot of people outside. Also like Mr. Günther, doing a lot of work for ABAP and also very community active. Andre Fischer, the product manager for OData. If you have any question about concerning OData, ask him. Thomas Fiedler, or for SID Berlin, the good Oliver Koh, or our teacher yesterday, Ingo Bräuninger, and for example, Christian Blum also with about 2.5 billion blog posts. So from my side, there are also a lot of people more outside the community. For example, like Emo with TrickTresor, with Christian Lechner with all his blog post information he shares. And in this community format, I would also say it's also a good time to say thank you to all these people who are enabling such session like this. For example, also our host for the present event. Thank you.
Thank you very much. Any questions?
The beer still cold?
Huh? Is the beer still cold? Let's look at it. Oh. Oh. It's getting warmer. I have to drink faster.
Are you considering to develop this further? So, for example, when I go to have a beer with a friend, they get a push notification when the temperature drops, so they can get me a new beer. Something like this.
Everything possible. I try to publish the code and all the stuff later on in GitHub or something like this, and then you have all you need to do it yourself. Okay. Thank you very much. We have our